Hello everyone, today we are going to learn about formal charge. First and foremost, we need to know what is the meaning of formal charge. Formal charge is an apparent charge on certain atom in Lewis structure. Formal charge is used to determine the most possible Lewis structure. Formal charge can be calculated by this formula. Formal charge can be calculated by the number of valence electron in an atom minus to the number of non-bonding electron and minus to half of bonding electron. For example, from carbonate ion, we can calculate the number of formal charge. From the formula given just now, to calculate the formal charge, we need to know the number of valence electron in atom. First, we calculate the formal charge in the central atom. Central atom is C atom that have 4 valence electron. So, 4 minus 2 number of non-bonding electron. As we can see here, there's no non-bonding electron here. So 4 minus 0 minus half of bonding electron. Bonding electron here is 1, 2, 3, 4. 4 times 2 is 8. So 4 minus 0 minus 4. So the formal charge we get in the C atom is 0. So here 0. Next, we are going to calculate the formal charge in oxygen atom. For here, okay. The number of valence electron for oxygen is 6 minus 2 number of non-bonding electron. Non-bonding electron here is 1, 2, 3, 4, 5, 6. 6 minus 6 minus half of bonding electron. Bonding electron here is 1. 1 times 2 is 2. So 6 minus 6 minus 1 equal to negative 1. So the formal charge here is negative 1. The same goes to the oxygen here. It's same, so the formal charge is also negative 1. For oxygen here, we use the same formula. So the number of valence electron of oxygen atom is 6 minus number of non-bonding electron 1, 2, 3, 4. 6 minus 4 minus half of bonding electron 1, 2. 2 times 4 is 4. So 6 minus 4 minus 2 equal to 0. So the formal charge here is 0. So from this Lewis structure, we also can calculate the total formal charge. To calculate the total formal charge, we just need to add all of the value here. So from this Lewis structure, 0 plus 0 plus negative 1 plus negative 1. So we will get negative 2. Okay, just now we had learned on how to find the formal charge by using the formula. Now, I'm going to share with you on how to find formal charge by using the shortcut way. To use the shortcut way, we need to know the number of valence electron of an atom, because we need to use the number of valence electron to minus it with the number of pair of attached to the atom. So, from what I said just now, we can conclude that to find formal charge, we need to know the number of valence electrons. So, the number of valence electron will minus the number of pair attached to the atom. Okay, now we are going to see the example. The example is CO32-, that is carbonate ion. Here, this is the Lewis structure. Now, let's find the formal charge for carbon atom on the central atom, on the central Lewis structure. To find the formal charge, we need to know the valence electron of C atom. The valence electron for C atom is 4. So 4 minus the number of pair attached to the atom. 1, 2, 3, 4. So 4 minus 4 equal to 0. So the formal charge here is 0. Let's see for the oxygen atom. Oxygen atom, the valence electron is 6. And the number of pair attached to the atom is 1, 2, 3, 4, 5, 6, 7. 6 minus 7 is negative 1. The formal charge here is negative 1. Same to this oxygen atom. Yes, negative 1. Let's move to this oxygen atom. Oxygen atom here, to find the formal charge, the number of valence electron of oxygen is 6. 6 minus the number of pair attached to the atom. 1, 2, 3, 4, 5, 6. 6 minus 6 equal to 0. So, the formal charge here is 0. To find the total formal charge, we just need to add all the formal charge here. 0, 0, plus negative 1, plus negative 1. So we will get negative 2. Okay.
I'm Alex, and today I'm going to show you how to use formal charge to find the most plausible resonance structure, okay? So, there are 3 characteristics. Of a stable Lewis structure. Yeah, so the first one, it will be formal charge must be closest to 0 or exactly 0 at all costs. The second point would be negative formal charge on the most electronegative atoms in a molecule. And lastly, it will be positive formal charge on less electronegative atoms. Take note for characteristic number 3, as it will normally be the central atom, as it is normally the least electronegative atom. Alright. Okay, guys, now I'm going to show you guys an example. Let's take NCO negative as an example, okay? Let's find the best resonance structure for NCO negative. Okay. Right. The first resonance structure. Okay, let's count the formal charge on this molecule. Okay. First of all, yeah, the valence electrons. Now the formal charge. 1, 2, 3, 4, 5, 6, 7. Normal number of valence electrons for nitrogen, it would be 5 electrons, but this has 7. So it would be formal charge of -2. But for carbon, 1, 2, 3, 4 is the same as normal. And for oxygen, 1, 2, 3, 4, 5 be +1, as a normal oxygen atom would have 6 valence electrons. Here's the second the second resonance structure, and yeah, you get it. Alright. 1, 2, 3, 4, 5, 6. It will be -1 then. As usual, carbon has 0. 1, 2, 3, 4, 5, 6. This one will be 0 as well, as that's the actual number of valence electrons you can find on a normal oxygen atom. And here's the third one. Okay. On this nitrogen atom, we can find 1, 2, 3, 4, 5. This is like the normal number of valence electrons you could find on a nitrogen atom. So it will be 0. And usual carbon has 0. Now for oxygen, 1, 2, 3, 4, 5, 6, 7, which is like 1 extra compared to the normal one. So it should be -1 here. Okay, since this one has a formal charge of -2, so it's not close to 0 compared to these two. So this one is out of the picture. As in for these two, it's quite close. So let's consider the second and the third factor. Is the negative formal charge on the most electronegative atoms? Well, the most electronegative atom would be fluorine. Then it will be oxygen followed by nitrogen. So you could say in terms of electronegativity, oxygen would be more electronegative compared to nitrogen. Hence, in this molecule, nitrogen wouldn't be the most electronegative atom. It will be oxygen, so this one is out, and we are left with this. So that's it, guys. I hope you guys learned a lot today. Yeah, so that's it.